This is Pre-Algebra Lesson 5-1, Comparing and Ordering Fractions. A multiple is the product of a number and any non-zero whole number. For example, the multiples of 2 are 2, 4, 6, 8, 10, etc. Those are all multiples of 2. The least common multiple is the lowest multiple that is common to 2 or more numbers. You use the least common multiple in order to find your least common denominator, otherwise known as the LCD. The least common denominator is the smallest multiple of the denominators of fractions. For example, if I wanted to find the least common denominator between 1/2 and 1/5, it would be 10, because that's the smallest number that both 2 and 5 will divide into evenly. Right, so least common denominator is the lowest multiple that 2 or more numbers will have in common. Now, there are 3 ways to find the least common multiple of numbers. You can list the multiples, you can use prime factorization, or you can use upside down division. No one method is better than any other, so we're going to look at all 3. Each method has its pros and cons, and there are specific times in which I use one method over the other, but no one method is technically more effective than another. The first method we're going to look at is what happens when we list multiples. Listing multiples of the numbers until you arrive at one that they have in common. This works best when you have small numbers, and it also works best if you can multiply really well. If you don't multiply well and you miss a multiple, you could be missing the least common multiple, and that can be very frustrating. So if we want to find the least common multiple of 7 and 3, I'm just going to list the multiples of 7 and the multiples of 3. 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, 7 times 4 is 24, now 7 times 4 is 28, see what I said about multiplying? 7 times 4 is 28, 7 times 5 is 35, 7 times 6 is 42, 7 times 7 is 49. I'm probably going to stop at this point in time and now start listing the multiples of 3. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, 3 times 6 is 18, 3 times 7 is 21. Aha, I finally found it, the multiple of that I've been looking for, right? The smallest multiple they both have in common is 21. So the least common multiple between 7 and 3 is 21. Works fine when your numbers are small, tends to be very tedious and very cumbersome if your numbers are very large. The second way of finding a least common multiple is using prime factorization. You write the prime factorization of each number, use the greatest power of each factor, and then you multiply. So, if you remember how to use prime factorization, because we did that in last chapter, if you didn't perfect prime factorization in chapter 4, it's going to come back and haunt you in chapter 5. So if I'm going to find the least common multiple of 16 and 36 by using prime factorization. So I'm just going to take 16 and I'm going to take 36 and I'm going to break them down to prime numbers. 16 is 2 times 8, 8 is 2 times 4, 4 is 2 times 2. Or you can use the upside down division for that. And you can say that, you can use division. I can say that 16 divided by 2 is 8, 8 divided by 2 is 4, 4 divided by 2 is 2. Right? Either way works, whether you want to keep dividing or you want to use prime factorization. With the factor tree, you're still using prime factorization. 36 is 6 times 6. 6 is 2 times 3, and the other 6 is also 2 times 3. Once you've found the prime factorization, you need to list it. So I'm going to list 16 and I'm going to list 36. 16 happens to be 2 times 2 times 2 times 2, or 2 to the 4th. I'm just going to list it as 2 times 2 times 2 times 2 for a moment. 36 is 2 times 2 times 3 times 3, right? Or 2 squared times 3 squared. Right? So if I'm going to list this, now I'm going to list them in the form of this is 2 to the 4th, and this is 2 squared times 3 squared. To find the least common multiple using prime factorization, you use the greatest power of each factor. So, the greatest power of 2 is 2 to the 4th, and the greatest power of 3 is 3 to the 2nd.
So the greatest common factor between 16 and 36 is 2 to the 4th times 3 to the 2nd. Okay? 2 to the 4th is 16, and 3 to the 2nd is 9. And 16 times 9 is 144. So the greatest common factor between 16 and 36 is 144. Prime factorization works really well when the numbers are big like this, because listing the factors of this going out, it would take quite a while before we got to 144. Now, the last way we find a least common multiple is what we call upside down division, right, or simultaneous division. Okay? I call it upside down division because you're basically looking at it and it kind of looks like it's upside down while you're doing it. Okay, so if I wanted to find the least common multiple of 9 and 15, if I have 9 and I have 15, I'm just going to divide them by the same prime number. You divide both numbers by the smallest prime number that will divide evenly into both of them. 2 is the smallest prime number, it won't divide into evenly. So then in 3 will. 3 goes into 9 3 times, 3 goes into 15 5 times. There is no number that divides evenly into both 3 and 5, so we can't divide any further. Now we multiply what we divided by what was left over. In this case, the 3 is what we divided, and the 3 and the 5 is what was left over, so the greatest common factor is 3 times 3 times 5. And 9 times 5 is 45. So the greatest common factor between 9 and 15 is 45. Upside down division works really well as long as you only have 2 numbers. Once you get 3 numbers, the upside down division is very difficult to make it work well. I use prime factorization when I have 3 or more numbers that I have to find the least common multiple for. All right, let's practice, because now we're going to add variables to this. Variables are easy. They're just adding some letters. So we're going to find the least common multiple of 12 and 15. Right? And I'm going to use this with the upside down division because it works pretty well. So 12 and 15, what's the smallest number that is dividing into both of those? That's 3. 3 goes into 12 4 times, 3 goes into 15 5 times. There's no prime number that divides into both 4 and 15. So my greatest common factor here would be 3 times 4 times 5. Okay, 4 times 5 is 20, 20 times 3 is 60, so my least common multiple is 60. And if I do 12x, 15x to the third, and 18x squared, like I said, this is really hard to do with upside down division because we have 3 numbers. So I'll use prime factorization for this one. So for 12, I have 2 times 6, and 6 is 2 times 3. I'm going to leave the variables alone for a second. 15 is 3 times 5, and 18 is 2 times 9, and 9 is 3 times 3. So for 12x, the prime factorization is 2 squared times 3 times x. For 15x to the third, it's going to be 3 times 5 times x to the third. And for 18x squared, it is going to be 2 times 3 squared times x squared. So now we take all of the prime factors that are to the highest power. So if I look at this, the highest power of 2 is 2 squared. The highest power of 3 is 3 squared. The highest power of 5 is 5. And the highest power of x is x to the third. So the greatest common factor here, not greatest common factor, excuse me, least common multiple. Why have I been doing that? That's terrible. It's not the greatest common factor, it's the least common multiple. Right there, that should be the LCM, not the GCF. The least common multiple should be 2 squared times 3 squared times 5 times x to the third. So this is going to be 4 times 9 times 5 times x to the third. Let's see here. 4 times 5 is 20. 20 times 9 is 180, so it's 180 x to the third. So the least common multiple out of 12x, 15x to the third, and 18x squared is 180x to the third. And I wonder if I put the greatest common factor back here. Yes, I did. Change this back to the least common multiple there. And let's make sure I didn't do it. Oh, I did it over here too. Least common multiple. Make sure you change all those. Bad me. That's what you get when you're not paying attention to what you're doing. You say the wrong things because there's a big difference between the greatest common factor and the least common multiple. Greatest common factor is used to reduce a fraction. Least common multiple is used to find a common denominator of a fraction. Very, very important because they are all different. Okay, when we want to order fractions, we must find a common denominator and then write all the fractions with the common denominator. So we're going to order the following fractions from least to greatest, smallest to biggest. We have 3/7, 1/4, and 2/3. So the first thing I have to do is find the least common multiple. So I need to find the least common multiple of 7, 4, and 3. Well, they're pretty easy to find prime factorization for. 7 is just 7, 4 is 2 squared, and 3 is just 3. So technically, I'm going to multiply them all together. Okay? 7 times 4 is 28, 28 times 3 is 84. So the least common multiple then is 84. So I'm going to take 3/7 and I'm going to change it over to something over 84. I'm going to take 1/4 and change it over something to 84. And I'm going to take 2/3 and change it over something to 84. Okay, now, out of my least common multiple, remember I got my least common multiple by multiplying 7 times 2 squared times 3. I have a 7 over here on the 3/7. I need a 2 squared and a 3, and 4 times 3 is 12. So I have to multiply the denominator by 12, so I have to multiply the numerator times 12, and 3 times 12 is 36. For 1/4, I have the 4, which is the 2 squared. I need the 7 and the 3, which is 21. So I'll multiply the bottom by 21 and the top by 21, and I'll get 21 over 84. For 2/3, I have the 3, I need the 4 and the 7. 7 times 4 is 28. So I'll multiply the bottom by 28 to get 84. I multiply the top by 28 to get 84. 28 times 2 is 56. So smallest to largest, this is my smallest fraction, this is my second smallest fraction, this is my third smallest fraction. And now you rewrite them back in the proper order, the proper form that they were in to begin with, which was their reduced form. So if I go and write this, I would say that 1/4 is smaller than 3/7, which is smaller than 2/3. From least to greatest, there we have it. And we found the common denominator first, got our equivalent fractions, and then compared the numerators, and the smallest numerator went first. Now let's compare fractions. Now there are two ways to compare these fractions. I'll teach you both of them. One way is to find a common denominator. Let's take 6/7 and 4/5. Common denominator between 7 and 5, since they're both prime, is 35. So 35 and 35. 7 times 5 is 35, so if I multiply 5 times 6, I get 30. 5 times 7 is 35, so I multiply 7 times 4, I get 28. And 30 35ths is bigger than 28 35ths, so this should go this way. Now, interestingly enough, there's another little trick that you can do. It's a little shortcut that you can do in mathematics. Right? You have to multiply in an x, but we multiply up instead of down. So if I was to multiply up this way, and then up this way. Right? So if I was to multiply up that way and up that way. 6 times 5 is 30. 7 times 4 is 28. Notice, same exact numerators as we had right here. And you can compare your fractions that way as well, as long as you multiply up. And then you can make sure because if you multiply down, they're going to be on the wrong side, and then you'll be comparing the wrong fractions. You want to move to the numerator side, not the denominator, so you have to multiply up. So I can use that little trick here. I can do 4 times 2 is 8 here. 3 times 3 is 9 here. 9 is larger than 8, so 3/4 is bigger than 2/3. Now you have to be careful when you look at number 3 with negative signs. And remember, a fraction is negative if the negative sign is anywhere. So what I tell people to do is move it to the numerator so that you don't put it on both the numerator and the denominator. So if I move it to the numerator, 3 times -10 is -30, and 4 times -7 is -28. Which one is larger? Would you rather be $28 in debt or $30 in debt? Personally, I'd rather not be in debt at all, but 28 is a lot better than 30, so that fraction, -7/10, is larger than -3/4. Okay, so there's different ways of comparing fractions. You can find a common denominator and compare the numerators, or you can use a little trick I showed you here. The little trick with multiplying up only works with 2 fractions. You can't do it with comparing and ordering 3 or more fractions. Okay, so if you have to compare and order more than 2 fractions, you need to make sure that you find a common denominator. And that is comparing and ordering fractions.